Welcome. My name is Rolf Christofferson. I am the Executive Director of the UC STEM Faculty Learning Community, and we host these webinars on topics that are related to the goals of our learning community, and that's namely improving the higher education teaching of STEM classes at the University of California, and sharing what we've learned in our different campuses with each other. But of course, we welcome people from any other campus as well. As I know, some of our viewers are not from the UC, but from other places, and that's great. So a little bit about the housekeeping technology that we're dealing with here today. This is Zoom, and Zoom has the capacity to ask questions. If you don't see it, if you move your mouse around, you'll find a Q&A button, which you can click on and type questions, and the speakers will see those questions and answer them at different points during the presentation. So we very much encourage you to ask questions. Anytime you feel like it, just type a question and eventually it will be answered by one of the speakers. Okay, so the next thing I'd like to do is introduce our speakers. Both are here at UCSB. Eduardo Gonzalez, raise your hand, Eduardo. There's Eduardo. He got his PhD at the New Mexico State University in 2013 in developmental genetics, and prior to coming to UCSB in the fall of 2016, he was an instructor at various institutions in the Southwest. The other presenter today is going to be Mike Wilton, who got his PhD at the University of Toronto in 2012 and then was a postdoctoral scholar at the University of Calgary. His area of research was in host pathogen interactions, interestingly, both plants and animals, so he's pretty diverse in his background. And following that, he came here again to UCSB in fall of 2016. Both of these individuals are lectures funded by our HHMI 2014 Science Education Project, and they're going to today talk about some of the things that they've learned and developed in the last couple of years. And with that, I will let them start. The title of their talk is Peer Mentoring, a Versatile and Scalable Approach to Undergraduate Instruction. So Eduardo and Mike, you're up, and I'm going to log off and let you proceed.
All right, well, thanks, Rolf, and thanks for everyone for logging in. It's really great to be here with you guys today and share a few of the insights that we've had while working here at UCSB. And what we want to do in today's webinar is kind of highlight how we've been using undergraduate learning assistants, or LAs for short, to basically use peer mentoring to help our students succeed in the biology major here at UCSB on campus. So a bit of background. UCSB applied for an HHMI grant in the 2014 cycle, and the grant focused on trying to address a specific issue. So what we're looking at in this histogram is two cohorts of students, where you have non-EOP students and EOP students. So EOP stands for the Educational Opportunities Program here in the UC system. And this is a combination of both parental income as well as parental education level, as well as first generation status for the students. And what you'll notice in this histogram is that the students who are continuing generation, so these light green bars, they are retained in the major at a higher rate than those of the EOP students shown in the teal bars. So you have this dramatic decrease of both groups, but it's disparate between the two, where the EOP students are leaving the biology major at a higher rate than those of their continuing generation peers. When you look at actually how the students are performing at UCSB, the first 2 years seem to be very important. And their cumulative science GPA is also different between these two cohorts. Again, what you have here in this box diagram are you have your continuing generation peers shown in the light green again, where there's cumulative science GPA, which is a very strong predictor of student retention in the major, is significantly higher than those of their EOP peers, which is markedly lower at almost just a pass of a 2.0. So this is a really important diagnostic and a differential between these two cohorts. So the idea behind this HHMI grant was trying to address this grade disparity between these two demographic groups of the students. This decrease in grade, as it kind of mirrored with the first image, is also seen in terms of student retention. So this is demographic data from 3 separate cohorts that were followed from starting at UCSB in their first year to graduation and completing their degrees. And what we have in the top 3 bars are the EOP cohorts, and then the bottom 3 bars are the non-EOP or continuing generation cohorts. And what you can see is that of the students who are coming in as pre-biology majors, those that are the continuing generation, the bottom 3 bars, they're retained at the major in biology at a much higher rate than those of the EOP cohorts shown in the top 3 bars. And the interesting thing here is that these students, the EOP students, are still completing their degrees, but they're leaving biology at a higher rate. So the Biomentors grant that was applied for in 2014 and awarded uses 3 distinct approaches to try to address this disparity in terms of student grade as well as student retention. So we have this logic model here where we have 3 factors that lead to student persistence in the pre-biology major here at UCSB, where you have academic proficiency, so learning how to learn and applying those academic skills in class to earn higher academic grades, a feeling like you belong to a community, right? So this is where we heavily use peer mentors and learning assistants, as well as self-identity and self-efficacy as scientists. So we have certain courses that we'll be talking about in today's class. And the idea is that we use literature and the previous education research to build specific interventions shown on the right-hand side of this logic model, where we have specific courses like MC1A and 1B. We have alternative sections or highly structured sections of these intro bio courses for our second-year students. These freshman biome courses, which are freshman seminars on metacognition, and then other sorts of interventions like near-peer biomentors or learning assistants that are employed in these positions, as well as small cures or course-based undergraduate research experiences.
So this diagram just exemplifies exactly the classes that we're currently teaching as part of this program. So as you can see, the first year, the students before our program had no classes whatsoever. So this is typical for the UC system, I believe, where the first year of biology usually require or fulfill their prerequisites, including physics, chemistry, and math. So there's no real biology for this first year students. However, for our program, after the program was instituted, we created this class called Biome 1, which we're going to address in just a second, as well as a cure, one of these courses for research experiences for undergrads called Rumble, and we're also going to talk about it. For our second years, we, before our course was implemented here, the traditional size of these courses were approximately 1,000 students for the first part of the intro series and approximately 600 students for the second part. After our course has been implemented, we have smaller sections of around 280 students, and what we're doing is we're giving this alternative way of teaching these introductory classes. So this is just an overview to simplify all the classes that we have. This is just a schematic on how we actually are using some of these LAs that Mike mentioned before. So as I mentioned, during our first year, we have this Biome series, which is a metacognition course for first year students that are pre-bio, as well as Rumble, our cure course for the first year. For the second year, we have both the highly structured intro bio series for 1A and 1B, the 2 sides of it, as well as a program that was instituted here before we arrived called Biomentors, which we also are going to mention. Now, as you can see, these are quite a lot of courses that require instructors, and therefore it's one of the challenges that we needed to address, and we did precisely that using LAs that are able to mentor and teach along with the instructors for this process, us, and they receive credits themselves for their participation in the courses. So for the BioMentors program, we use MCDB 184 credits for the students that are volunteering to help, and for the other courses, we have another code, MCDB 183, for them to receive for participating in things like Biome, Rumble, or the intro courses. One of the key elements that allows us to implement this way of teaching is the fact that we, through the HHMI grant, are able to renovate this space in our campus to allow this small team-led or peer-mentored groups to actually happen. And this is a typical active learning classroom where you have whiteboards all around the walls of this space, as well as individual tables are movable and monitors in each one of these tables. So due to the development of this room, we're able to implement some of the practices that you're going to see in just a second. By the usage of the LAs in our courses, we're addressing several challenges just by the structure itself. So for instance, we're promoting this sense of community and belonging that we were mentioning before. Also, you're dramatically decreasing the student to instructor ratio, as well as implementing this high active learning structure that sometimes is really hard to do in a large room setting. We also are addressing indirectly the fact that for many of these courses, and it's a reality for our department, we sometimes struggle to get teaching assistants, but the fact that we're using this LAs ameliorates all these different challenges. And the usage of peer leaders or peer mentors to help with these different aspects of courses has been well documented, has been done since 1993, are the first articles that mention this, this particular use of LAs. And there's several articles that document the different advantages of implementing the system, including improved academic performance and reasoning skills, as well as to increase student retention. And particularly interesting for us was this asymmetric benefit from underrepresented minorities and other disadvantaged populations. So one of the important aspects for our LAs for all our programs is the recruitment. And the way that we do it is essentially, as you saw before in that diagram that I was showing you, we select both juniors and seniors that have been successful in their course load, specifically in the courses that they're going to be LAing for. And they go through this application process where they express that they want to be part of the LA teams, and we analyze the applications essentially to address any potential issues with grades, and also just to evaluate the student's application itself. What are the interests? And most of them are very genuine and very I think it's important to mention that they're very I'm losing the word exactly, but they have a great interest in actual helping other students to give back, and that's why their main reason why they're applying to this programs. One great thing about this LA programs is that this property of self-perpetuating model. So many of the LAs that are currently applying were or used to be mentees for earlier versions of the program. So this is one of these aspects that talks about how this is easily, or could be easily implemented in large courses. One last thing that it's important to mention for everybody that we recruit as LAs, we have weekly trainings, and these consist of 1-hour trainings where we talk about subjects that are directly related to the course content, but also we have a little bit of time to discuss things like leadership and address group dynamics, because it's important for the LAs to have these tools available to them so that they can actually implement them in their mentoring. If you're more interested in how this actually works, these training sessions, we have developed our own little guide, a handbook that is specific to our course, but I think that has some little things that you can use if you're interested in implementing this for your own courses. And there's also multiple resources online. One of our favorites is this book by Vicky Roth, the Peer-Led Team Learning Handbook for Team Leaders, an excellent way of introducing these people to the works of a peer mentor.
So we have a few questions that we're going to address. And I think this is what we should do for the rest of the webinar as well, which is if you have questions on the topic, please feel free to post them, and then we'll answer them at the end of kind of that section. So the first question was, were the peer leaders able to work with students without an instructor or TA present, and were they paid or receiving credit? So the peer leaders do need to have some instructor of record in the classroom with them, so at UCSB. So for us, we have to have a TA present. But if you had an active learning classroom that could seat 100 students, for example, you could have one graduate teaching assistant there and then multiple LAs to kind of man each table. At UCSB, as Lalo alluded to, we have a really great student body that is willing to work these LA positions for us for credit, excuse me, for course credit. So we don't actually pay them here at UCSB. And then the second question was, how many hours per week are LAs required to work for this project? So to earn 1 unit of MCDB 183 or 184, it's supposed to be at least 10 hours.
Yes.
So we have the LAs come to training about one hour of training per week, and then they usually come for at least one section, and then we have assignments that they're completing prior to coming to the training as well, right? So these include things like readings or small assignments that we will discuss at the training that are relevant to kind of helping build this peer mentoring program.
All right.
So we're going to now focus on the first year aspect of this BioMentors grant, and we're going to focus in on the biome experience as well as Rumble. So Rumble is this course-based undergraduate research experience, whereas biome is a small seminar that can be scaled looking at metacognition. So what we noticed about the pre-biology students at UCSB is that they really struggled with the Gen Chem series. So upon arrival as a pre-biology student, a first-year biology student, they have to take this Gen Chem course, and it goes throughout the first year. And it's a really strong predictor as to whether or not the student will succeed as a biology student here at UCSB. So we designed these biome courses, MCB 11, Biome 1, MCB 12, Biome 2, and MCB 13, Biome 3, to kind of mirror each of the Gen Chem courses throughout the first year of the students' time at UCSB. And they have slight different flavors. And students can choose to take 1, 2, 3, and any combination of them. So you don't have to be locked in for all 3, and you don't have to take Biome 1 in order to take Biome 2. So what we really did in MCB 11, Biome 1, is to drill down and help the students learn about metacognition, so the science of learning, as well as how to adapt to the university expectations. And when we first arrived here, we didn't have learning assistants, and it was a little harder to kind of get the student buy-in. But as soon as we implemented having peer mentors at each table with these students, basically telling the students that this is how it is at UCSB, you have to study hard, and here are the tips and tricks that I've learned over the past 4 years, we got a lot more buy-in. And the idea is to build these small learning communities of the students with each other where they can reflectively learn as the Gen Chem series progresses. So as to how to study for specific types of professors, or studying for a midterm versus a quiz. And having a mentor there to kind of lead them through this process. Just briefly, because we won't be talking about Biome 2 or Biome 3, the different flavors of these move away from pure metacognition and resilience towards more kind of focusing on scientific topics, so discussing scientific research, as well as popular culture consumption of that research. And then MCB 13, which we're currently teaching, is all about careers in biology. So showing students or exposing students to a wide variety of different careers that they maybe have not considered. So we talked about the active learning classroom before. What we do with the Biome Learning Assistants is that this is a class of approximately 130 students that are split up into multiple sections, 35 students typically. There are 24 mentors per quarter in this course. So each table that you see in this photo has a mentor sitting at it, and they mentor 4 to 6 students, as we mentioned, once weekly, and they receive course credit for this. So one thing that we were very interested in is that we have over 1,000 incoming pre-biology students. We want to make sure that the programs that we designed were scalable. So we didn't actually have targeted recruitments, but we did work with various different types of approaches to try to get a student population in these biome courses that were representative of the total pre-biology major. So in this histogram here, what you see with the yellow bars is the total pre-biology major in terms of the demographics. In this case, it's race. And what you can see in the other colors are kind of the progression of our recruitment. And I do want to highlight in the most recent version of this course that we've got data for, that we do have a really good representation of student demographics in the biome course versus the overall pre-biology major. And the way that we did this was through multiple modalities, where we did email recruitments. We worked with the EOP, the Educational Opportunities Program Office, to recruit underrepresented students. As well as we also have a welcome session during the first week of class, and we went there and introduced ourselves and told students about this course. So using all these different approaches, you can see that we clearly got a fairly nice representation of the student population in this course. So does it actually work? This is data showing you violin plots that are looking at the participants and non-participants of Biome 1, so MCV 11, and their Chem 1A grades. So this is their first introductory chemistry class that they've taken. You have about 130 students that were in Biome, and you can see that there's a statistically significant increase in terms of student academic performance, where you have a mean of about 2.6 versus a mean of about 2.2. So almost a half a grade point average increase, just by having these peer mentors who are guiding these discussions about metacognition, resilience and grit, and persisting through hardships. And you can really see it's really pulling up the tail, or these lower performing students. Since we're interested with the HHMI grant at looking at underrepresented minorities and EOP students, we want to make sure that this isn't just that we're helping high-performing students. So we controlled for this by looking at incoming math, as well as language or verbal, and combined SAT scores. And there are no differences between the populations. So when you're taking a look at the underrepresented minority students, you do see that, again, that there is a significant improvement in terms of the Gen Chem grade of almost a half 3-point average as well, all right? So this is clearly showing that through the introduction of metacognition delivered by near-peer learning assistants, these upper division biology students, you can get a significant improvement in terms of student academic performance. Coupled to that, we were interested to see whether or not students were also being retained in the major. Since we've been here for 3 years, we've been able to collect data on our first generation of students, whether or not they're being retained in the biology major beyond their second year. Remember that students were retained at a very poor rate for the first 2 years, but after that, upon entry into our junior and senior years, our retention rate goes up dramatically. And what we saw is that you do actually see an improvement in terms of student retention with students who have participated in the biome classes. So we have 3 questions here.
Yeah, so the first one is, how much does your program emphasize team-based learning, and how do the students respond to being placed into teams? So for the biome class, we don't discuss any content, right? In any biological or chemistry content. Everything is all based on this metacognition ideas and the subjects that we covered. Now, in terms of our actual classes, the classes that we have changed, we're going to talk about those in just a second, but essentially one of the classes of the typical 4-week or 4 classes a week classes that we teach has been converted into one of these workshops where the students work on, a small section interacting with the RLAs. We're going to talk a little bit about that in just a second. For biome, again, it's entirely about metacognition and abilities and skills to survive college.
One thing to add to that also is that all the courses of Gen Chem are taught by 4 typically at least 4 different lecturers, and we don't place students into each biome class based on their lecturer. So you can imagine that these courses do slightly vary. So it's not that we could have a uniform kind of team-based learning environment where we could be like, okay, let's work on this book problem together. The idea here is to try to teach them about reflective learning and the science of learning.
The second question is, in biome students outperforming peers in 1A, looks great, thank you. Is there a self-selection effect at all? There's always that possibility. We have ways that we just developed for the 1A and 1B series to try to factor that out. So we're going to show you in a few slides from now. We are able to construct a model, a generalized linear model, regression model that allows us to predict the grades of the students based on certain predictors. So we can apply that model and see if their students can perform the prediction from the model. That's one way to separate this idea of self-selection versus are the students actually gaining something from coming to biome. So we're going to show you in just a few slides. If you just hold on for a second, we can show you that. The other question is 24 LAs, 130 students. To scale up to 500 students, you need approximately or more than 90 LAs. Do you think you can recruit that many biome LAs and still have biomentors as well? How do you train this number of LAs? Mostly think about the difficulty of finding a time that will work for LAs. Okay, so first of all, more than 90 LAs. That will be close to pushing it to the limit probably. We haven't had an instance yet where we have not enough LAs. We always have enough for all these courses, for biome, for biomentors, for our alternative section, and for Rumble. As how much more LAs we will need, yes, it's a really big number.
I don't necessarily think it would be that big a number because in theory, we take this many LAs because we want to give them the experience, but we could get away with maybe 12 LAs, right? So
sure.
It's a matter, most of your investment in terms of investment is in terms of training. The class itself is actually quite short, it's 50 minutes. So what I initially would think about is if we were to scale this up, you would have LAs double or triple up with the times that they mentor. Right now, we're kind of stingy with that because we want to give this experience to as many students as we can possibly take. So, I mean, if you double up or you make students do 2 or 3 sections, you can dramatically increase the scalability of this while remaining with relatively fewer LAs. We have run into issues with the timing, but the way that we get around that is that we have 2 set times that the students can choose from, and usually they're either late at night or they're early in the morning, and that covers everyone. And if this is what they want to do, and a lot of students here do want to participate in this program, they'll make it work.
Yeah, so typically what we do is Mike takes over one of the 2 times for the training, and I take the other one, and then the students can choose depending on their schedule. Another question: what is your students' demographic ratio of white, Black, Hispanic, etc.? This slide right here for Biome 1, I think, addresses that question.
So, I mean, our biggest population since UCSB is now an HSI, so we have about 30% Hispanic, Chicano, Latino, right? A relatively smaller indigenous population of students, and relatively smaller Black as well, and relatively high Asian, around 20%.
Yep. Yeah. Next question, specifically what happens in the 15 minutes mentoring session? So essentially the students come into these sections prepared. They have to have either read an article or watch a video or hearing a podcast audio about the subject that is going to be covered that week. And then the LAs moderate the discussion about the article that was covered. And they usually work towards completing a task. Sometimes it's just a discussion, but in other cases, for instance, we have one of the first ones for MCD 11 is that the students need to write down in a schedule all the activities that they are invested in, and try to analyze how they're spending their time. So it's very useful for students to realize, right, where is their time going, and the LAs give tips and ideas on how to rearrange their schedules to make them more efficient. So that's one of the different activities that they do. So at the end of the session, the student not only had a productive discussion about an important aspect about college life, etc., but also has this insight from a peer about their current activities, what they're doing, etc.
One thing that we found really useful is a book by Richard Blake called Making the Most of College. And I recommend it to every parent that I see during faculty outreach events when kids are coming to UCSB. And we model a lot of our approaches for MCV 11 based on that book. It's a really easy book. Again, that's called Making the Most of College. It's a really, really good book to read. And the last question is, have you tracked why students who are in or not in the biome class drop out of the major? So have we done qualitative assessments? Have we done interviews or focus groups? We have not.
Not for biome, for sure.
We do track that with the data from institutional research, so we can obviously watch that progress. This is where this figure came from. That is definitely something that we could look into next. We have done, I think, quite a bit of quantitative research, but we've done a little bit less in terms of the qualitative research in terms of dropping out. But that would be a very valuable insight to have.
Yeah, I mean, typically the literature about the subject refers to those 3 points that we mentioned before. Students not performing well in classes, students feeling that they don't belong, the imposter syndrome, right? And then the lack of self-identification of as a scientist, as a biologist, as part of the department or the university. So those typically are the main reasons are written in literature, but it will be really interesting to assess what's the actual reasoning behind the students, particularly at UCSB.
Last question. Since the commitment is 10 hours a week, what do LAs do beside attend the weekly training and run the 50-minute session? Do they attend the chem lecture?
They don't, and that's, I think, what you were alluding before, since they are not necessarily fulfilling those 10 hours per week, because they only do the 1 hour training and the 1 hour of their sessions, and then the assignment and that all the students do prior to coming to training. There's still room for them to double the amount of classes that they help us with. So maybe that's a little bit of what you were alluding to by doubling or tripling their load. Yeah.
We do also ask the LAs to contribute in terms of reflection on improvement of the course. So this is like our first cohort of students that are now LAs, and they've been both students now as well as learning assistants. So they do actually have more informal communications with us about improving the course as well.
Yeah. Right. So our second experience for the first year students is Rumble. And I love this acronym because it allows me to say every time that I start the class, are we ready to rumble? But essentially it's a research course for undergraduates, and its emphasis is the molecular biology experience. So right now the idea is to provide first year students with a real, true, authentic, discovery-based research experience. We're using two main projects in order to do this. The first one is DNA barcoding of plants and insects, and what that entails is to go outside to sites of restoration sites around campus managed by the museum here at campus. And what they do is collect plant and insect specimens, bring them back to the lab, and then we identify them using DNA barcoding. The second project is the isolation of antibiotic-producing bacteria from the environment. As you probably know, the antibiotic crisis that we're going through, the superbugs arising, etc., lead us to find new antibiotics. And one way to do it is by isolating fastidious bacteria that are hard to harvest on normal lab conditions. So these two projects are what we do, or what we focus for Rumble. Now, in the case of Rumble, we use learning assistants as models, right? And the idea of Rumble is to, as you remember from that logic model, we want to increase or foster that sense of belonging and that sense of self-identification as a scientist in training. And I'm sure that many of you can relate to that feeling of wanting to become a scientist when you first started working in a lab, right, and doing some actual experiments, holding a pipette, etc. So this is what we want to give to Rumblers, and the LA serve as those models, right? Those near-peer models that were in the shoes of our students a couple of years ago, and they can look up to them and say, yeah, I want to become them. And what Rumble is a very small course, given that it's only a lab, it's only 20 students. And usually we have between 3 and 4 LAs to mentor them. And the way that we do it is that we assign a LA per table, but they are free to rotate and to move through the experiments. And the lab is itself 3 hours long, once weekly, and they also receive credit for doing this. And I love this picture. 1 unit, okay. 1 unit, sorry, we have a question from Rolf, a comment?
No, 1 unit is 5 hours per week for
yeah.
LAs. Yeah, we were wrong. It's not 10.
Yeah, it's not 10, sorry. Little
So
clarification from the boss. Yes, so receive 1 unit of MCV 183 course credit. And oh, I was saying that I love this picture because we have these two people here. I don't know if you can see it in the, can you see it here? I don't know. The 2 people on the right corner of your screen, they are our LAs for this particular cohort, our first cohort. And then the people next to Mike on the other side of the picture were 2 students of that cohort. But now those 2 students are actually our LAs for Rumble. So again, this self-replicating cycle of LAs coming back to mentor other students from the classes that they participated in. It's true for Rumble as well. We're very lucky with Rumble because we have, unlike normal science, I guess, or real science, we actually got 2 really interesting results. One was one of the barcodes, one of the plants that we barcode didn't had in our file in GeneBank, so we were able to contribute with that DNA barcode to GeneBank. And as you can see in that small rectangle right there, the red rectangle, those are the names of all the students that participated there. So now forever and ever, every time that you look for Diplicus or Canticus, you can see the names of the students there, and that really meant quite a bit for them. And the other thing that we discovered for Rumble is this strain of antibiotic producing bacteria. We don't know what it is yet. We're working on characterizing what it is, but it is able to inhibit the growth of MRSA. So that's actually quite interesting. And the way that we're tracking the effectiveness of Rumble is through pre and post examinations, particularly to test their knowledge of both biology, experimental design, and the techniques that you use, that we use in Rumble, as well as that scientific self-efficacy. So we have an instrument that has been validated before that addresses that particular concept. And this is just a picture of the current, which is a local or the UCSB newspaper, and featured this story as well.
So we have a question that was how we looked at the impacts of mentoring and the impact on the LAs themselves, and we have not done that yet, but that is something that we're very interested in looking at and starting to develop over the summer. So that we'll have a discussion at the end if we have time, and that's something that we would be very eager to hear more about as well if people have insights into that. So we're going to start to shift gears a little bit into the second year. So we've shown you the interventions at the first year level. So as Lala mentioned, before the HHMI grant, the introductory biology series was taken in the second year of study here at UCSB, and they're a very large enrollment, traditionally lectured courses of over 1,000 and approximately over 600 students for MCV1A and MCV1B together. So the 2 programs that we're going to talk about next are the BioMentors program, which is a co-curricular program that is meant or designed to help the students in that traditional section excel in intro bio. And then the second approach that we're going to talk about at the second year level are the alternative, highly structured sections with 280 students. And Lal will be talking about that as well. So BioMentors, again, takes place in that active learning classroom that we have here on campus. And the idea here is for the students to sign up out of that larger enrollment traditionally taught section, and they're paired or they're matched up in terms of groups of 4 to 6 second year students with an upper division, a third or fourth year biology student who has been quite successful academically. And they meet twice weekly. So they meet for about 1 hour early in the week, and then typically 1 hour later in the week. And the idea here is that the BioMentor is meant to provide metacognitive training and advice and any sorts of insights that they have in terms of second year biology, but they're not a tutor typically, or we're trying not to have them act as a tutor. So in this picture, what you have are various BioMentor groups. There's 3 of them shown here with range of students, and they'd be covering the course material that had been lectured in the class that week or coming up. So the BioMentors themselves, the program itself consists typically of about 100 to 120 second year students per quarter for that introductory MCB1A and MCB1B. There's approximately 15 LAs per quarter. This number varies depending on how many students we can recruit, and they guide the discussion for the 4 to 6 students for about 2 hours a week. And these students receive 1 unit of MC184, which is mentorship in biology. So what you have in this photo here is a former HHMI funded lecturer, Lynn Griffin, who is leading a training session with about 7 of these BioMentors. And the training typically happens once a week for at least an hour as well. So BioMentors, and this is a simplified box plot, but we can actually show you a box plot with dosage. The more that students go to BioMentors, the higher their introductory MCB1A or MCB1B grade is. So it shows a statistically significant increase. The students themselves are controlled by looking at their cumulative science average prior to their second year. So this is actually probably the strongest predictor variable in terms of student success is their cumulative science average. And after a year, we have really good resolution in terms of that. So there's no difference in terms of the students incoming, but there's a significant difference in terms of their grade itself. As a side note, we don't have the data here, but I can tell you that students that do participate in BioMentors are retained in the major at a higher rate, a significantly higher rate than their peers who do not participate.
So parallel to the big section that BioMentor aids, the traditional section, we created an alternative, highly structured section for intro bio, and everything among the 2 sections remains the same in terms of the learner objectives and the focus, the coverage of the material for intro bio. But in the alternative section, we decided to incorporate it a lot of known strategies and tools and techniques used to improve student outcomes based on active learning. One of the major components of this is the creation of this workshop. So in the alternative section, the students are required to go to essentially a discussion section where they work together in small groups of 4 to 6 people in order to solve problems that are related to the material that was covered in class. Most of the times this material addresses real-life problems that are based on the knowledge that they are acquiring in lecture. In here for these workshops, that's essentially the main place where we use our LAs here. So typically we have 280 students divided in 8 workshop sections. And so we have 2 to 3 LAs per section. So there's about 35 students per group of LAs. And they also meet 1 hour weekly for training and 1 hour weekly for one of these sections. Most of these are nowadays, most of our LAs are students that took the class, this alternative section class with us. And so they know the dynamics of the class and they know the material excellently or very, very well. And they do receive the MCV 183 course credit as well. So again, for these alternative classes, through the different methods of recruitment that Mike mentioned before, we have tried to make the traditional section and the alternative sections comparable in terms of their demographics. That's represented by this graph right here. As you can see, there's very, very little difference among the groups. But one of the things that we wanted to make sure of was to keep the rigor in the classes the same. So one way to address that was to have similar questions in between the two sections for the exams and the final evaluations. So what we did here is to show you the differences between the questions that we shared among the two sections per exam. So more than 50% of the questions of these examinations are shared. And as you can see, the alternative section here on green is does significantly better, about 10% better in each one of these questions, as represented in the graph here. Also, if you look at the actual average of the class, when you divided the class itself per URM versus non-URM, you can see that in the traditional section, the underrepresented minority students have a mean of 2.15 average points, whereas in the alternative section, they actually have a 2.767. So half a point of average higher than in the traditional section. Not only that, but this, if you compare it to the traditional non-URM students, is still, if not significantly different, but still it shows an upward trend when in that comparison. So our students are actually doing, especially the URMs, are doing better in the courses. This is the generalized linear model that I was talking about before. So you're able, through analyzing years from historical data for the students, we are able to create this generalized linear model that predicts the students' grade based on demographics, including their science GPA, for instance. So in this graph, what you're seeing is the predicted grade that based on this model versus the actual earned grade of the student. So everything, so for instance, if you're predicted to get a 2.5, and I don't think that you can see that.
I think you got it.
Okay, so you can, if you have a 2.5 predicted and you have a 2.5 earned, you should be on that red line there's towards the middle. However, if you're underperforming, then you're going to be below the red line, and if you're overperforming, you're going to be above that red line. So in the traditional section, what you can see is that there's a lot of this cluster of students underneath that red line, meaning that they're actually not performing to the level that they were supposed to according to the model, whereas that number of students that are below the line is reduced in the highly structured section, so that, you know, meaning that their learning outcomes are way better. Also, and this is quite important because of the HHMI grant that we have, we can see that this is particularly true for EOP students. So the number of students under that red line in these graphs is much, much smaller in the highly structured section versus in the EOP traditional section. So this approach of highly structured classes definitely has an impact not only in everybody, but differentially in the EOP and underrepresented minorities population. This is just a representation or a way of seeing continuity in the major. Just the number of people that go from MCV 1A to 1B, and in the right side of the graph, it's higher in the alternative section in green than in the traditional. And then the second course in the series is MCV 1B, and those students that pass that class go to the next class, which is the EMB3. And again, the students represented in the green bar tend to go in a higher rate than the students represented in the traditional section, represented here in teal. Again, alluding to that retention effect that we were aiming for. Finally, for 1A, one of the things that we are interested in understanding and knowing is the sense of belonging that we have been talking about, and we wanted to measure that, and we did that through a validated survey instrument. And as you can see in this graph, the density of students that this is based on a Likert scale. So you can see that there's a shift in this sense of belonging measurement in the alternative section versus the traditional one. So overall, the students are performing better, particularly URM students and underrepresented minority, and EOP students. And also they have a higher sense of belonging in our class. And we believe that most of that is attributable to the contribution of the LAs to our courses.
And that's something that we want to follow up on, is looking at the impacts on the LAs themselves, but also how the LAs are impacting sophomore and freshman feelings or perceptions of belonging in the major. So what we've shown you, in short, is that at UCSB, based on the Biomentors HHMI funded grant, we have undergraduate learning assistants that are typically juniors and seniors that have been academically successful, who act as near-peer learning assistants for small enrollment courses like our CURE Rumble, which only has about 20 students in it, for intermediate or larger scale courses like our seminar classes at the freshman level with about 120 students, as well as our large enrollment 280 student intro bio course as well. And so we have this discussion question that was, how do we measure the effectiveness of having undergraduate learning assistants? And we throw that out to you as well to see if anyone has any leads on that as well.
Yeah. I have some ideas in mind on how to answer that question, but we'll love to hear from you as well if you have any suggestions or experience. Should we do the questions?
Sure. There's a question here that says, when you say biomentors participation in the box plot, do you mean students who are biomentors or students who get help from the biomentors? So that refers to
students who are participating in the biomentors program.
Yeah. So this is a grade earned by second-year students who either are attending, so that's that light green color, biomentors, or not attending, which is that teal box plot shown here. And what we did here is we binned it. They had to attend at least 5 of the sessions.
The second question that we have is, do you have look at the impacts mentoring has on the LAs? That's something that we're going to address in the near future.
So Rolf, do you want to come back?
I am back.
You're back.
I'm back. I wasn't sleeping. Okay. So you posed a question, and we could do it by text, but if anybody actually wanted to say something, I could turn on their mic and video camera, and we have somebody with their hand raised. So I'm going to promote them to be a panelist, and that's Shanna from UCLA. I assume you raise your hand because you had something to say, Shanna.
Your volume's off.
You got to unmute your mic, or I do. I'm not sure which.
There we go.
Okay. So can you hear me now?
Yes.
Okay. You ended with the question that I'm exactly trying to answer, and I've been trying to answer this isolating the effect of LAs. And so I'd love to hear your thoughts on the problem, and that you all are encountering too, is usually when you add LAs, you make a lot of changes simultaneously with adding LAs, so it's hard to isolate the effect of LAs. That's what I think you're getting at. The best things that I've been doing so far is actually randomly assign LAs to some sections and some not to some sections, but as I'm sure you can anticipate, you know, some people argue that's unethical, and I don't necessarily disagree with them. There's also the argument that you design activities to be run by LAs, so when you don't put in the LAs, that's not a fair comparison. But these are the things I've been trying, and honestly, it actually is hard to just see an effect of LAs because they usually go along with these structured activities and other things. So basically, I'm going to say I don't have a clear answer. I don't know if you all have thought about the randomly assigning discussion sections and found any way to get around the concerns about that.
So the one that we have discussed before is exactly what you suggested, to have these control groups with no LAs, but only TAs. You're absolutely right. We have also thought, would that be all right, right? Would that be okay, ethical? I think that one other way that we can address that is in this survey that we have for sense of belonging. Some of the questions can be modified a little bit to ask the students whether what's exactly what made them feel like they belong, right? We see this trend of our students feeling more that they belong into our course than in the traditional section, and either giving it for a Likert scale and just select how much of these elements make you feel like you belong, like interviewing with us in office hours, versus coming to LAs or having the LAs in the room helping, etc. So that's one way around it. It's more of a self-assessment, and I know that sometimes that raises people's eyebrows, right? Like, oh, it's self-assessment. But I think that there's not going to be an easy way to answer that, and that's why maybe you need to have several elements that address that question, and that may be one.
Okay, great. I think there's a question about biome courses.
Yeah, there's two questions. Yeah. So the first was, were there any negative outcomes? So we did notice that students who, for example, come to biomentors less than like 3 or 4 times do know better, right? So I mean, you do have to hit a threshold in terms of certain aspects here. I think one thing that I've been struggling with is that although you do see a disproportional improvement of student grades for EOP and URM students, it's still not at the same level. Like, we haven't provided equity, so we're trying to figure out what additional steps can we do in order to promote that further. So there's still work to be done there. I think the first year that we taught Biome without near-peer learning assistance, Biome 1, we learned a lot, and there was very little effect there. We saw no change in terms of student grade in their Chem 1 class, but we learned after that first quarter with MCB 11 that we had to get near-peer assistance in that classroom to help us. So they're not technically negative, but they're not positive results.
Yeah, I guess one thing that maybe also, if I add something to that, is that something that is not necessarily something that we have measured, but something to be aware of, is that it is important for the people that go into this discussion section to be moderated, right? Because sometimes these small spaces will allow underrepresented minorities to feel intimidated to participate into the groups. So that's something to be conscious about, and make sure that your LAs understand and know how to direct conversations to avoid precisely that. So yeah, that's something to be aware.
Do you want to answer that one? So is enrollment in Biome courses open to anyone, and how do you encourage EOP students to apply?
So as Mike mentioned a little bit, we use different strategies. Yes, it is open to everybody, but
all biology
students, yes. But we have resourced to several different things. First, we are in very close contact with the advisors from the EOP office. So they help us by promoting the courses, by showing the students how well the other students are doing based on their attendance to Biome. Then we also get the list of the EOP students and directly email them to promote our course. We usually include some of the data that we have there, so the students see that it's beneficial. So that's how we get these populations to enroll. It's hard. It's one of the hardest things that we have to deal with. Usually, we have to do several attempts before we get good numbers of these populations. Yes.
So a lot of benefits of this program for biomentors and LAs or their students and peers will take a long time to see. Do we have a sense of what these students want to do with their biology degrees and what they actually wind up doing? Are we training them for what they want to do? Is there a voluntary tracking program for graduates in place?
not yet, but that's an excellent, excellent suggestion. I think that ultimately we have to cater to the students, right? And that's something that we haven't done so like yet in terms of their ultimate career goals. So yeah, something to definitely consider in the near future.
Rolf, do you know if the UC tracks graduates?
That is a great question. I know there is a survey on exit, but after that, I think primarily it's left, to my knowledge, it's left primarily to the alumni associations who are tracking them like crazy to get money out of them.
Yeah.
I don't know of anything beyond that, but you know, the other UCs may have more resources to do that. It's pretty resource intensive to do that, and you know, given our resources, we probably should focus on students that are actually here.
Yeah.
And so it would be good to have more of that, but I think it would cost money, and we have to choose how we're going to spend our dollars.
Okay. And then the last question is, I'm curious if the participants, especially those in the metacognition sections, do better in their other or subsequent STEM courses. Seems like a good fit for the LAs since you don't need to worry about their knowledge and course content. So that is something that is a great suggestion that we have not done yet. And it would be easy enough to do, which is just compare the cohorts as they move through the major and see whether or not their grades are disproportionately or statistically higher than their peers that did not participate. But that's definitely something we can follow up on.
In the literature regarding that, it's a little bit hit and miss. Like there's some articles that report a lasting effect of metacognitive programs, whereas others says that it's very course specific. So it is a very, very interesting question. We should look a little bit more into that and try to figure out what's the deal with our course.
What frequency of the bio EOP students do you contact to get? What frequency of the bio EOP students you contact do you get to enroll in bio? How many students sign up after you send that email?
Oh my God. So usually the EOP populations, as you saw in the demographics, are in the hundreds. And I usually get between 20 or so students for Rumble. And I actually think that we have the demographic here for here.
Yeah, you got it.
So yeah, so from those hundreds, and this percentage is based on 120 students. If you put together Chicano Latinos and Blacks, Native Americans, Asians, in the dozens, right? So yeah, it's hard, and people have tried in the literature to explain that phenomenon because it's not exclusive to UCSB. People that put out these programs for underrepresented minorities and other populations at disadvantage sometimes face the same issue. And it does have, like, there's a paper from Silvia Hurtado in UCLA that refers to this effect of at least the Latino community of rejection to everything that will make you look weak and everything that can make you look different from your peers. So I think it's very culturally ingrained, the fact that Latinos don't like to ask for help or to go to this kind of things. And something that we have to fight against, right? And modify our strategies in order to accommodate for that that particular view of the resources. But yeah, it's hard. Recruiting is really, really hard.
Okay, so I'd like to wrap it up. You've gone over time, which is allowed, but it's time to finish. If there are no more questions, I'd like to thank Lalo and Mike for doing a great job. Really appreciate that. And I'd like to thank all the viewers who gave lots of great questions, and I hope you enjoyed and found this useful to you. So with that, I'm going to log off and say goodbye.
Thanks, guys.
Thank you.
Thank you. Oh, one more thing. We're going to have a meeting here in Santa Barbara next fall. So those of you who are interested, please keep that in mind. I'll be sending emails out about that as soon as we figure out when and what we're going to do. We're working on it right now. Okay, that's it. Bye.